Welcome to qnawire.
We have here this system with an angular velocity going in the counterclockwise direction, and we're asked to find what the angular momentum is about this point G. And we're given that the weight is equal to 10 pounds, so we convert that weight into mass by dividing it by the acceleration due to gravity, and we'll get a mass that's equal to 0.3105. And then we're also going to find the mass of each individual rod in this system by taking that total mass and dividing it by 8, since 8 is the total amount of rods in the system. So to solve this problem, we're going to need to find the x, y, and z components of the angular momentum. And these are the formulas corresponding to each component. So we'll start by finding what the moment of inertia is in the x direction. So in the x direction, this is going to be equal to 4 times 1 over 3 times mr times a squared plus 2 times mr times a squared. And then we can substitute in mr and a squared, where a squared is the length of 10 inches, and we're going to convert it into feet for our calculations. So now Ix is equal to 4 times 1 over 3 times mr times a squared. So the 10 inches converted into feet squared plus 2 times mr times a squared. And this will give us an x component that's equal to 0.08983 pounds second squared per feet. And the moment of inertia about the xy direction is going to be equal to 0, since if we look at the free body diagram of the system, notice that in the xy plane, we don't have any rods lying about that plane. All the rods only lie in the xz plane. So that moment of inertia is going to be equal to 0. So now the moment of inertia in the xz direction, that's going to be equal to 2 times mr times a squared. So we plug in mr, and we plug in a squared. And this will give us a value of 0.0539 pounds second squared per feet. So we now have all the components that we need to plug into these equations for the different vector components. So the x component So I'll calculate each component out first. So I'll start with the x component. So h of gx, this is going to be equal to 0.08983 times 12, the angular velocity, and this will be equal to 1.07796 pounds seconds squared per feet. Remove the squared off the seconds. So now for the y direction, this is going to be equal to 0 times 12, which is just going to be 0. And now for the z direction, this is equal to negative 0.0539 times 12. Thus, this will be equal to negative 0.6468 pounds seconds feet. So we now have our I component and our k component of this angular momentum vector. So we can write that vector as negative 0.0 so was this value here. So 0.0 so this I component 1.07796I minus the k component, which is 0.6468k. And this is the final answer.